Hello everybody, my name is Leonardo Moraes and today we are gonna talk about the research paper entitled Design Principles and a Software Reference Architecture for Big Data Question and Answer Systems. This is our agenda for today. So first a brief introduction talking about the motivation, the proposal. We have two main proposals in this paper. One is the design principles and the second one is the software architecture. We performed two distinct types of experiments in this paper, and finally the conclusion. As we know, data has been created at a high velocity, high volume, and varied. So this is big data scenario, big data context. And according to multiple specialists, majority of data from 80% up to 90% is unstructured information like text, image, audio, and so on. In this way, companies produce several textual documents containing valuable information for both internal and external users. So for internal users, we can think about product reports, financial documents, and for external users, we can think about product documentation, product description, FAQ, and so on. Okay, so we have a lot of data, a lot of textual data, but how can we extract information from these documents? It's not trivial. First, because of the big data itself, and second, because they are textual documents. It's not so easy to extract information from textual documents. And here comes the big data question and answer systems that our system can handle with big data scenario, a lot of data coming at high velocity, and extract information from textual documents. Okay, so now we know why it's important to create a big data question and answer system. But how can we build that system? And that's the main subject of this paper. And in this sense, we have two proposals. First is what? What are the requirements, the design considerations, the guidelines that we need to follow to create our own application? So we propose a set of design principles in this paper. And second, it's the software reference architecture, that is a software template that tells us how to build that system. And these are the two main proposals of this paper. First is the design principles. So a set of requirements and design considerations that should be followed to help you create a great system. We proposed a set of principles based on business, data, and technical aspects. Let's talk about them. So first, business. B1, the first principle. The system needs to provide a proper answer to the user. So they must have a reference for each answer. B2, the user access on allowed documents. B3, the system needs to understand natural language, so the user you send queries as questions. And B4, the system needs to summarize the answer, so it does not make sense returning an entire document with 20 pages. It's much better to return just a summarized answer. So in summary, the business principles refer how to the user interact with the system. And data principles. So D1, the system needs to persist the whole data. D2, the systems allow or need to collect data from different sources like PDFs, Word, web, so different formats, and but this data come from different sources like trusted web pages, internal databases, support a variety of data formats, PDF, Word files, web-based files, and so on. Support a huge volume of data, so we are talking about big data, and support inserting and updating data. So we don't want to create a fraud in knowledge. We want to constantly update this knowledge of the system. In summary, the data principles refer to how the data is manipulated by the system. And the third aspect is the technical. So the T1, the system needs to implement it using modular components, so independent components. So in this way we can easily replace or improve one component without affecting the other ones. They need to be flexible, so they are independent, and I can do or implement the way that I want using this programming language that I want. The system needs to store analytical data, so the managers need to understand how the users are interacting with the system, so we need to store analytical data, and ensure security artifacts to avoid any security issues. In summary, technical principles refer how to use good practices to implement your big data question and answer systems. Our second proposal is the big QA, a big question and answer architecture. This architecture is composed by 6 layers. We're going to talk about them later. And it's important to mention that these layers are split in 2 main groups. One is the horizontal layers, where the layers has strict connections, like input layer on connects to the big data storage layer. And we have the vertical layers, that are layers that can be connected to any of the other layers. Like I can use a security artifact to ensure a security connection between the input layer and the big data storage layer. Or I can use a security artifact to ensure an authentication system in my API component, and so on. Okay, the first layer is the input layer. This layer is responsible to basically ingest files into the system. So we are thinking about different types of files, as mentioned, PDF, Word, and so on, from different data sources, trusted web pages, internal databases, internal data lakes, and so on. And we are basically sending all of these files to the data lake. So in the big data storage layer, we have 3 main components. The first one is the data lake, responsible to store the raw data, the raw information, so the files with 20 pages. And another responsibility is process and clean up this data and start the cleanup and process data into the document store. So here we are thinking about store the golden data and index this data. So we receive a document with 20 pages. We run ETL functions like remove images, remove text, and split the document into several phrases or sentences, and store each of the sentences into a document store and index the sentences. And the third component is the metadata repository. Basically keeps all of the metadata information regarding to these documents. So what were the data input, the data input method, the data source, what are the ETL techniques that I use to clean the sentences, and so on. The third layer is the heart of the system, the core component of this architecture is the big querying layer. So this layer is responsible for processing to receive the queries, process understanding what the queries want, and generates an answer to the user. And here we have 2 main components. One is the document retriever. So it's basically responsible for retrieving documents. I receive a question from the user and connect to the document store, so the pre-processed documents, and retrieve what are the most useful sentences or phrases to the question. So I return the top K sentences to a question. The second component is the document reader. So this document, you read the query and the top K retrieved documents and generate one answer for each phrase or each sentence. So imagine that I set up my parameter K equal 10. So I'm going to generate 10. I will retrieve 10 documents from the document store and later generate 10 answers, one for each retrieved document. The fourth component is the the communication layer. It's basically an interface through the user's questions. So we can think in components like front end web page, an API, and so on. And this component basically sends questions and get answers from the document reader. The fifth layer is the security layer. So it's basically responsible to address any security issues like network connection, credentials, data governance, so who can access what. And as mentioned, this is a vertical layer, so can be applied to any other layers. And the latest layer is the insights layer. So it's basically the data analysis of the system. So it's responsible to keep all of the data like usage information and provide tools to the managers of the systems to analyze how the system is performing. And as we can think, it can receive data from multiple layers, like what were the latest questions, who accessed the systems, and so on. Let's talk about the experiments. As mentioned, we performed two distinct experiments in this paper. The first is the real-world case study, where we want to investigate and instantiate a system and explore different pharmaceutical queries, pharmaceutical industry company queries. And for that, we are using two data sets. One is SQUAD, a multiple domain data set which contain documents about computer science, healthcare, movies, and so on. So with more than 18 sentences. COVID QA, so a data set focused on coronavirus with 12 sentences and question and answers. And these are instantiated system. So we are expecting to receive the documents as JSON documents because both data sets only has the JSON documents. We don't need to keep the raw data, so we are not instantiate the data lake, only the document store, and for that we are using the Elasticsearch. And because all of the documents, the sentence, it's already cleaned and preprocessed in the data sets. And as query engine, we are using two algorithms. One is the BM25 as document retriever, a well-known algorithm in information retrieval systems. And the second, it's the Roberta. It's a deep learning model based on BERT as document reader. So this model will generate answers. Read the document, read the sentence, and generate one answer for each one. And RaceTech as API. Okay, the first query. What law regulates drug marketing in pharmaceutical industry? So we want to extract a name entity between these 80,000 documents. So we are only using SQUAD dataset right now. And it's important to say that the system were able to retrieve the right documents, as you can see here in the top 3 answers. So the first and the second one is from the right document, and the first answer is the right one. So Prescription Drug Market Act of 1987. So this instantiated system were able to extract the right answers between these 18,000 documents. And the second query, when was the Luder-Delbach experiment carried out? So here we want to extract a date information through the system. And this is the top 3 answers. And as you can see, the first is the right answer. So we retrieve the right document, antibiotics, and the answer 1943. The third query, it's about an augmented cases. So the first and second query we use on the squad dataset, and now we want to combine both datasets, so the squad and COVID QA, and make a question about COVID coronavirus only, to see if the system is able to mix different data sources. And yes, as we can see, between the top 3, all of the answers come from the same document, so the coronavirus question and answer dataset. And the first and the third answer, the first and top 3, are the right answers. So in summary, we performed distinct types of query, analyzing 3 distinct business scenarios. Okay, so the second experiment, it's more a laboratory experiment, where we want to extensively test different algorithms to propose what are the best setup algorithms that you can use to instantiate your own system. So here we conduct 27 experiments, and we are investigating the recall score. So we are just focused on the document retrieval. For each query, each question, did I retrieve the right sentence or the right document? So this is what recall score means in this scenario. We experimented the BM25, the FDF, and a deep learning model, dense passage retriever, DPR. And we used 3 distinct datasets, open domain datasets, so for multiple domains, squad, adversarial QA, and DORC, summing up more than 25k pairs of question and phrase. So for each question, what was the right sentence or phrase that I must return? And we test different values of k. So k equal 3, 10, and 12. It's important to say that in the literature, the people usually test with k up to 100. But in real world, it's unfeasible returning 100 answers or 100 documents for each query. So because of that, we focus with small values of k. And these are the results. We can see that in squad dataset, BM25 was the best one. In DORC, the BM25 also was the best one. And in adversarial QA, the dense passage retrieval was the best one. So in overall results, BM25 was the best and generic approach to use. But on over complex data sets like the adversarial QA, it seems better to use deep learning models or dense models like dense passage retrieval. So depending on their context, we suggest always start with BM25, the best general solution. But if you want to focus for a specific use case like only medical things, maybe it's better use dense models. So now let's talk about conclusion. So the first proposal of this paper is the set of design principles based on business and user interaction, data manipulation, and technical implementation aspects. The second proposal is the big QA, so the first big data question and answer architect that matches all of the design principles. And it's important to highlight a few things, like this architecture deals with real-world and dynamic applications, so we are expecting to update the data over time, provide a reference for each answer, so we are not generating an answer. We are extracting information for retrieved documents, so the documents have the right answer, we are just extracting information from them. And we provide a reference for each answer. And we are also addressing security issues and analytical needs. So many related studies does not care much about the security artifacts and analytic studies. So we think that it's important to keep both in this architecture. And we can incorporate business rules on top of the systems, like data governance. So who can access what? My manager can access my my payments, but for example, I cannot access the payments of my colleagues and so on. So we also performed two distinct experiments in this paper. So a real world case studies where we instantiate the system and test with different queries for pharmaceutical industry, and also a laboratory experiment running on top of 27 experiments using multiple domain data sets. And of course, all of the code is publicly available on GitHub. And as future work, we can think about laboratory experiments using document reader. So as mentioned, we focus on the document retriever, but we will also want to explore the document reader part, investigate more the insights and security layer. So as mentioned, the related studies does not care too much about that. So we think that it's important to concentrate our energies in those layers. So the insights layer and security layer. And of course, instantiate new case studies. So we developed one case study for pharmaceutical industry, but we can perform different case studies for different domains. And that's it. Thank you for your attention.